Welcome, math lovers, to this next video of our channel from the series 100 Problems Around the World. Today we have selected a problem from Bangladesh Math Olympiad of 2025, so very recent, in their final national phase. The problem states that find all prime numbers p and q such that p times p plus 1 times p squared plus 1 is equal to q squared times q squared plus q plus 1 plus 2025. Well, from the first look, it seems a little bit of a messy problem. Very too much factors in this given equation, but we will try to make it good with what we have. Pause the video and comment your solutions, and if not, let's go through a solution step by step together. As always, we have covered the solution in order to go through it together. So this is a little bit of heavy calculations, so please bear with me. We rewrite the condition of the problem, so we are given these two prime numbers, and we are trying to find these two prime numbers p and q such that they fulfill this given equation. Now, the first natural idea of what to do would be that of trying to expand both sides of the given equation. And we will get that from this form by doing some simple calculations of both sides. We will have that p to the fourth plus p to the third power plus p squared plus p is equal to q to the fourth plus q to the third plus q squared plus 2025. So we notice a pattern over here that on both sides we have p and q on the same order of exponents. So what do? We take all the factors of the right hand side of q, we take them on the left side, left hand side, and p we take it on the right hand side, and the given equation becomes that the difference of the fourth powers of p and q plus the difference of the third powers of p and q plus the difference of square of p and q is equal to 2025 minus p. Now, we know the simple formulas of calculation for the difference of powers, and the first factor becomes p minus q times this factor over here. These second factors become p minus q times this factor, and the third factor becomes p minus q times p plus q is equal to 2025 minus p. So the right hand side remains unchanged. On the left hand side, we factorize p minus q, which is a mutual factor for all these three expressions, and we will have that p minus q, which multiplies this expression over here where we have only positive numbers, is equal to 2025 minus p. Now, given this equation, of course, it is very difficult to solve without any further conditions, we notice something very important in the form 2 of the given equation. We see that in order to constrain possible values that p can take, we see that p to the third power, it is smaller to p to the third power plus all these factors over here, because these factors over here are positive factors. So p to the third is smaller than this sum over here, but on the other side, this sum over here, which is part of the equation number 2, will be smaller than the absolute value of 2025 minus p, because in order for this value to be equal to 2025 minus p, it should be multiplied with p minus q, which, given that p and q are natural numbers, will also be a natural number. So this value over here will be smaller than the absolute value of 2025 minus p. Or we can, from this expression, we derive that p to the third power is smaller than 2025 minus p. This is a very important result that we just got, because now we can do some observations regarding p. So from the inequality number 3 over here, we can immediately deduct that p can be smaller or equal to 12, because if p is equal to 13, for example, or a higher number, it will be equal to at least 2197, which would be greater and would not fulfill the given inequality over here. So we just constrained p to the values of all prime numbers smaller or equal to 12. Now we know that all possible values of a prime number smaller or equal to 12 could be p is equal to 2, 3, 5, 7, or 11. But again, for p smaller or equal to 5, from equation number 1 over here, we have that the value of the left-hand side is equal to 780, which itself is smaller than 2025 and also even smaller than 2025 plus a positive factor. So we say that p cannot be smaller or equal to 5. And we are left to check only two cases, when p is equal to 7 or when p is equal to 11. Now for p equal to 7, we make the substitutions on the initial equation, and we will get that q squared times q squared plus q plus 1 is equal to 775, which is the difference between the left-hand side factor minus 2025. But 775 can be expressed as 5 squared times 31, and itself 31 can be expressed as 5 squared plus 5 plus 1. Now, from a direct comparison of factors in this left-hand side and this right-hand side, we see that q is equal to 5. So one solution that we found is p and q equal to 7 and 5. Now, when p is equal to 11, we will get from this equation over here that q squared times q squared plus q plus 1 is equal to 14,079, which itself is equal to 19 squared times 13 times 3. We clearly see that we cannot have parity between the left-hand side and the right-hand side because we cannot furtherly transform this expression over here. So we might deduct that q is equal to 19, but the other factor could not be equalized to 13 times 3. So we say that in this case, there are no solution to the given equation. So finally, the only solution of this problem is p and q equal to 7 and 5. Please let me know if you could find some easier way in order to solve this equation. Let me know in the comments, and thank you for taking time from your day to follow the videos of our channel. Hope that we could earn like and subscribe from you. See you on other uploads. Up to then, goodbye.